So Philip is going to be going over, I guess, a continuation of one of his last sessions where he went a little bit over the Inventor API and what that means for automation within the actual CAD application itself. And I'm sure Phil will go ahead and describe what he's going to be going over today, but we're going to continue that, start generating some geometry using the API as opposed to something like iLogic. So if you have any questions, go ahead and chat them in at any time. And Phil, I guess I'll let you take it away from here.
So like Nigel said, we're going to be doing a continuation of my last AVA where we talked about connecting Visual Studio with Inventor through add-ins and kind of getting started on that. But that last thing left us basically at setting everything up and clicking a button that gave us a message box, which is not really automation, right? So for this AVA, we're going to go and take that further where we're actually going to be creating some basic geometry. Just really quick about me, I'm an application engineer at KETIV. Like Nigel said, my background is in mechanical engineering from Brigham Young University. I've worked for General Motors on their knowledge-based engineering team, doing automation, and also for Autodesk on their education field team, teaching professors and students about CAD and how to use it. So that's me. Let's kind of go for an overview of kind of the steps of how we're going to go through this. And I'll go ahead and turn off my video at this point. First off, get focus back on PowerPoint. When we click this button right now, we're seeing a message box from our old template. And if you haven't seen the last AVA, after this, I would very strongly suggest going back and watching that and running through it, because it'll get you to where we are now. So we're going to, instead of launching that message box, we need to make a Windows form so that we can, put in some basic inputs. For our application, it's going to be simple, but for yours, it could be a whole lot more complicated. So then after that, we're going to write some code that will sketch a circle, create a sketch and draw a circle on it, and then we'll extrude that circle with code. Once again, very simple. Your engineering rules will be much more complicated. And then finally, we'll connect the inputs to that code so that the user can drive where that cylinder is and what's the radius and how much is the extrude distance. So very simple. So first off, like I said, we're going to create a form. Now I'm going to show you in PowerPoint, and then I'm going to switch over to Visual Studio and do it with you. So you'll be able to see it twice. Hopefully that'll help. We have our solution of our project that we created using the template. We're going to just simply right click on the project over here in the solution menu and come down to add and go over to form for Windows form and click on that. And that's going to launch this form over here where it's going to allow us to create a form, and we'll rename it. I always forget to rename it and have to rename it later. And then it will pop up on our Solution Explorer just like that. So let's go do that. I'll switch over here to Visual Studio. Just to show you kind of where we start. This is it. We got a message box, so we got to go change that. So I'm going to come over here to our Solution Explorer, right click on the project, come down here to add, and click Form. This will pop up this menu. Windows Form is already selected. I'm going to name this Shape Creator Form, but I mean, you could name your form anything under the sun. So we'll go ahead and add that. And you'll see that it pops in over here. It also creates us a blank form. We can, resize it as we need to. So that was the first step, pretty simple. So next, go ahead and switch over. We have a form, but if we click our button, it's still going to launch that message box. So we need to go in and comment out that message box line and put in 2 lines that will launch our form from the ribbon button that we created last time. And so for time's sake, we're not going to test after that, but it's always a good practice to test often and early. So let's go do it. So here, we're going to go back into the standard add-in server. This is the template that we used last time. And we're going to navigate down to about lines 98 and 99. You'll notice that you have this private sub that is calling an event handler. It handles our button that we created and on execute. So every time that button gets clicked, this code is going to get run. And so this is where you'll hook up all your applications to buttons. So we are going to, with an apostrophe, comment out that message box. And instead, I've left this code in here. We are going to create the form. So first, this shape creator form will match this name that we created here. It's kind of like the mold that we make. We could make 5 of these forms, but this is the mold. So we're going to make an instance of this form like that. And then we are going to call .show on that instance, and that will launch that form for us. And we pass in this gobbledygook here. So it's just a wrapper. Don't worry about it for right now. And we're passing in Inventor application mainframe. So with these 2 lines, it will launch our form. Okay. So once we get the form launched, it's just going to be a basic form. It's not going to have anything on it. So why don't we add something to it? Adding features to our form is really quite simple. We'll need to have the toolbox for forms in Inventor. I'll show you how to launch that. It's just really simple in the view. And then we'll populate our form with some inputs and buttons. And I'll give you some tips on that as well. So let's pop back over and go back to our empty form. So here's the toolbox. Let's say if this wasn't here, I'm just going to close it down. You can come up into view. These have a lot of windows. If you're missing a window on Visual Studio, it's probably over here. So I'm going to select the toolbox. Boom, it's back. And for this simple form, we're just going to get a label, and then we'll get a text box so that we can input some numbers in there. I'm also going to get a button because we need to be able to say, go do it. Now, I'm going to talk about 2 properties on these features of the form. One is text and one is name. So text will just change what shows up on the screen. So if I take a label and I say, hey, I want a radius down here on the properties, notice it changes it to radius. Now the name changes the name of the feature in the code. Excuse me. So if I wanted to do something with this label, like change its position or what it said automatically, I would want to change the name. I don't really want to do that with a label, but I do want to do it with this text box. So I'm going to go up to my text box name. It says text box 1, which would work fine, except that if I didn't know that it was the first text box. So I want to do it something that will remind me what it is. So I'll just write txt for text box and put radius. You could name it anything you want, but it's really useful to use common nomenclature, especially when you're working on a team. So there's the name. Then down here on the text, this is an input box. I'm going to put 0 in here just so that we have a number in there. And I'm going to change the text align to right because I like numbers on the right side. Go ahead and save that. Now I'm just going to shift control copy and paste and drag because we need an X coordinate, a Y coordinate, and an extrude distance. Okay, and then rinse and repeat. Let's change this text. So let's just do something simple like X, Y, let's see, extrude distance sounds good. And then we'll go back and we already have the zeros because we copied it, but the names aren't right. So there's the text radius, that one's right. Let's go and change this text box to txt_x. We'll keep it simple. Now you can imagine with a lot of inputs on your automation project, you'd want to maybe get more specific with these names. Because there are some automation projects we do that have tabs and tabs of inputs because we're dealing with very complex automation or engineering rules. So I'll just put extrude distance. There we go. Now the last thing to do is rename the button and change it so it doesn't say button 1. So here it's a button, so I'm not going to put text. I'm going to put BTN and let's name it create. Button create. Come down here and change this to create. And there we go. Little tedious of creating forms, but it wasn't bad. We'll resize it because we don't need it to be that big. And now I can go ahead and hit the start button. This will run it in debug mode from how we set it up in our last AVA, which means it will launch Inventor. You can't see it because it's launching on my other screen, but I'll drag it over here once it gets set up. And here we go. Bring you up. No, come on. Bring you over. There we go. Now we chose to put our button in the part tools ribbon. So I'm going to go into part. Come down to here to tools. Now, just as kind of a refresher, if you're having trouble finding your add-in, ours is right here, go into add-ins and it might be blocked. Okay, go find your add-in, this is demo. It's not blocked. Cool, it's working. But here we can go ahead and click this and boom, we get our form. We've launched our first form. We can type things in here. We can hit the button, but guess what? The button doesn't do anything. We didn't put any code behind it. So that's what we got to do next, is put some code behind our button. So let's go back to our PowerPoint and talk about that. Okay, so now that we're going to talk a little bit about code, let's talk about where you can get code from, because you don't just have to know this stuff. There's actual documentation online. And if some of you have been doing iLogic automation, you've probably been familiar with the Inventor API documentation. You can use that and a lot of your iLogic rules in the Visual Studio with the language VB.NET. There's a little bit of difference. So if you've never gone to the documentation, you can just search Inventor API documentation online. This is a Brian Eakins article. He's always a good read, but on this one, you can click on it. It'll have a link there. Once you get here, I would suggest just bookmarking it. That's what I do, so I can get back to it quickly. It's Inventor 2018, but it works for our purposes. So you want to come down here to Programming Interface and get the Inventor API reference manual. And it's a little off the screen here, but click on Objects. And it'll get you a list of all these different objects that you can create in your automation. We're going to pick a planar sketch for this example. We'll also use extrudes, extrude feature. You can just, Control F and search them on your browser. And here we pulled up a code sample. And this is kind of iLogic-y code. So I'll show you how we kind of translate that. So here's the iLogic code that we got off of the documentation. Translating is pretty simple. You don't need to call set on things. So you'll notice dim component def as that, and then we just skip set and set it equal to it. Same here. You'll notice they're getting a surface off, a face off a surface to do their sketch on. We'll do a work plane. That'll be a little different. And, sketches.add. So this is kind of the basics of doing a sketch, and you can get it right from there. So you don't just have to know it. The documentation has it there for you. So the next step that we're going to do is create a sketch and a circle. And I'm going to go through this because of time constraints pretty quickly. I have the sample code already here, and I'm going to go by it line in line. But basically, we're going to get those inputs from our form. We're actually going to make event handler for that button and put that code in here. We're going to get the document, the active document. We're going to get the component definition off that active document. We're going to make a sketch on it on a work plane, get a center point, and put a circle on it based on the radius. So let's go do it. So here, easiest way to make an event handler on a button is double click on that button. If it's the first time you've done that, if it's the first time I'm still in debug mode. Close off debug mode. There we go. It will create this little sub which handles button. That's our button that we made, .click. So here, I'm going to just go get my commented out code that I saved here for this AVA, a little Martha Stewarting here, and drop it in here. And then I'll uncomment and kind of talk to each line. So really quick, I'm going to delete this so we can do it from scratch together. So here I'm just dimensioning up different double variables. I need to reference those text boxes that we created. So here we named all of our text boxes TXT to start with, so it's really easy to find them all. And I need the radius, right? So there's text radius. Now, if I leave it like this, this is only referencing the actual text box object, not the value inside. And so this won't work. I need to actually call .text on it, and that will reference the value and assign it to that variable. Now, some of you might note that this is actually a string, which we get from the text box, and we're trying to put it into a double. So what we're doing is called an intrinsic, my mind just blank, definition. We're translating it intrinsically. Normally, if you had more time, and we're doing this really quick, you'd want to put in some error handling, because somebody could put like dog into that text box and it would make your application blow up. So shout out to QA engineers that can think of all the wrong things to put into stuff. So we're going to go ahead and just forge ahead. We'll say text box or text underscore x dot text. And we're just kind of filling all this out, getting the information from our form. XT, and get the extrude distance text box and call text on it. So now that we got those variables of whatever the user inputted, now we got to do something with them. And this is where we start to reference Inventor. So I'm going to go ahead and uncomment everything up to making a sketch. So you'll notice Visual Studio is going to yell at us. And this is because it doesn't know what transient geometry is. It doesn't know what a part document it is. These things live in the Inventor namespace, and we haven't told it that. So one of the ways you can fix this, notice that it gives us some hints. It's like, hey, something's wrong. I think I might be able to figure out what's wrong. Yay, Visual Studio. So here it says, hey, if I put Inventor dot in front of it, that's going to work, because then I know where to find it. But if we do that, we're going to have to do that on every single one. And since we're going to use Inventor a lot here, I'm actually going to use a different option. So here it'll import Inventor at the top of the file, and that way all of these know where to find it in the Inventor namespace. So we're going to make a transient geometry object. Don't worry too much about this. This is how we're going to make a center point later. When you're making points or lines, you're going to make them off the transient geometry object. We'll also grab the active document. You'll notice both of these use this G_Inventor application. By using our template that we made last time, it gave us this for free. So this is a global variable we can access anywhere in our application. And it just grabs the Inventor application, which is super useful. So here we'll call active document. We grab the document. We're going to grab the component definition off of that document. And then we're going to make a sketch. We grab the sketches off the component definition and we'll add to it. You'll notice this is a pattern that you'll grab a list of objects off of the component definition or a sketch or something, then you'll add to it. And we're going to add the work plane. This is the XY plane. The second work plane in Inventor, unless you do something funky in it, is always going to be the XY plane. Inventor works on a 1-base list, so it goes 1, 2, 3, 4, where most application or programming things operate on 0 base, so 0, 1, 2, 3. So that's a gotcha that can grab you there. So be aware of that. So here we make a sketch. Okay, let's go ahead and draw a circle on that sketch. So let's uncomment here. So now that we have that sketch, we can call, well, first we got to get a center point. Oh, look, this is wrong. Let's go grab the Y coordinate, not the Z coordinate that doesn't exist. So the center point we need to pass into that circle call. So we're going to make a center point using that transient geometry object we made, create point 2D, and we just have to pass in 2 doubles. It knows what to do. We'll name it center point. And then we're going to pass that into this call where we say, hey, sketch, give me your sketch circles. Then I want to add one by center radius. So we're going to give it a center point and a radius. That'll give us a circle. So if we ran this right now, which would be a good idea if we had more time, we'd be able to see that circle populated. We'll run it, but we'll run it after we extrude. So there we go. That's how we grab the circle. So let's go back to PowerPoint real quick. We did it. We sketched a circle. Well, we haven't ran the application to prove it, but we'll prove it after this next one. So then we have to extrude the circle. Okay. And this is just going to take 4 lines. It's not that complicated, but we do have to make a extrude definition, which is something that you might have not known existed if you were using Inventor just manually. So first, in order to get an extrude, we need a profile. So when you're making sketches for automation, you don't want to make sketches that have multiple profiles because it's really hard to pick the profile. But if it's a basic sketch that is an obvious profile, it's easy to grab it. So there's sketch profiles, add for solid. That'll give us that profile of the circle we made. Okay. Then we're going to make an extrude definition, which is just kind of going to define what the extrude's going to be like. We'll call it off of component definition, features. Once again, we get a list of things, features, extrude features, and then we're going to say, hey, add to it, create extrude definition. Now, these lines, once again, you can grab them off of the API documentation. You don't just have to know them. So we're going to pass in the profile. Another thing that's fun to see, if I go ahead here, Visual Studio will give me a hint of what needs to come in here. So it says create extrude definition. And we need a profile and an operation. Now here we're going to do join, but I mean, you could do intersect, new body. We'll stick with join. Then on that extrude definition, we got to set how far it goes. So there's the extrude distance, and we want it to be positive. So we just call extrude def set distance extent. And then the last and final line, we make the extrude. So we dim up an extrude as an extrude, and we're going to call off component definition, features. Once again, that list thing, extrude features, add. And we pass in that definition that we created. Whew, that was a lot of talking. So hopefully that made sense along there. We can field some questions afterwards. So now that we got this all done, let's run it, see if it works. So I'm going to go ahead and hit start. It will load up Inventor. Again, off screen. Drag it over. Go to part. And you can put these add-ins in assembly. You can put them in different places, not just the part toolbar. So let's go to shape creator. Boom, there's our form. We don't want a radius of 0. That makes no sense. So let's go to, let's offset this from the origin a little, like, I don't know, for -2. And let's give it an extrude distance of, I don't know, 8. Hit create. Boom. There you go. We made a cylinder, guys. Congratulations. I know it's a really simple example, but you can kind of imagine when you expand with your engineering rules, the power that this has. So why don't we really quickly pause there? Nigel, do we have any questions before we kind of end talking about the implications of this?
I'm taking a look right now. It looks like we don't have any related to this specifically. So I guess if we have more stuff to cover, let's just keep chugging through it.
Yeah, we're kind of done with the demo here. I just wanted to spend a little time and talk kind of on the applications of this a little bit of how we can use these add-ins. So there's a lot of automation opportunities here. Some of the things we do as a team, like this, you can create custom features that you can, add these features onto existing parts if you're doing the same thing over and over again. You can also create an assembly from a library of template parts. We do this a lot and can provide customization and automation that will allow you to get a design out quicker and with less engineering hours. Pushing parameters to child parts to update them, creating a drawing automatically where you, as long as you have kind of a standard template of how you want your drawing to show up, you can push views and dimensions and populate it automatically, so your engineers don't have to do the basic stuff that takes up time. They can just focus on the details. Comparing parameters between files. Let's say you had a lot of versions and you wanted to see whether somebody changed a parameter in one of them, so you can go undo it or whatever. That's possible. And also verifying your engineering rules, seeing where a design breaks certain engineering rules that you can set up. So all of these are just kind of tip of the iceberg of stuff that we can do with automation and stuff that we could perhaps get into in future AVAs. And so just kind of as an ending before a Q&A, next steps, if this stuff really interests you and you want to know more, I'm happy to have a short conversation with you. You can go ahead and shoot me an email. I put my email there, philip.cox@ketiv.com. And we can talk about, maybe getting a little bit of roadblocks out of your way, what makes most sense in your positions and possibilities. I'm happy to do that with you. If you want a little more mentoring, our team does offer mentoring. And also if the project you want to do is far above in scope and you've got this awesome thing that's going to save you a lot of money and time, that's what our team does. We do automation projects, and you can kind of see some of the stuff we offer there at the website under the services engineering. And then also future AVAs. I'm hoping to be able to kind of expand, since this has been mostly basic things, maybe get into specific stuff that you guys want to see in future AVAs. So anyway, if you got some questions, Nigel, before after that.
Yep. Yeah. Let's run through those and about, having those conversations with you, Philip. I've been on a couple of those with customers and Philip as well. And yeah, I've seen, it's like, oh, it's like, I've seen the light bulb turn on in somebody's head, right? In the sense that like they were kind of lost before and they're like, oh, this is the direction I should take this in. And then take that conversation and just run with it. So definitely utilize us as a resource to be able to get your project started, or just help you get past some of these roadblocks that you guys see in the way. So let me go ahead and jump into a couple of questions. So Dennis is saying that he might have missed something. Does the code add the add-in in the Inventor ribbon?
Good question. So that is, like you said, you might have missed something. So a previous AVA that we linked in this one that I think we did in, was it September, Nigel? It was a little bit ago.
Yeah, it was late last year.
It will walk you through how to get that template and get it all set up so that you can get that button in the ribbon and have it launch. And then after you kind of do that, then you can come back and watch this one, and it will bring you up to this point. So yeah.
Cool. And then just a note from Andy. Spoke to Andy this morning, actually. Been doing this for a while now, and it's wonderful for creating assemblies with the iLogic parts that he created before learning the Visual Studio portion. Super versatile, and thanks for the great AVA. Andy, thank you for joining us many weeks, many weeks. And then Jared too, Jared Metler. Jared, nice to hear from you as well. Jared mentions when he runs the debug, he gets a lot of XAML binding failures. Are they important? Are they normal?
So I haven't seen those XAML binding failures myself, but if you want to send me an email and I can quickly look at them. So I haven't seen them when putting things. You might just have a setting error from last time. So happy to give that a look.
Yeah, Jared, you can just add that to the existing email string you have with Philip and myself, and we'll go ahead and take a look at it. So cool. Just one way to go out there. This just another example of like the situations in which someone gets stuck and they hit me up and I'm like, hey, Phil, please help. And it works. Oh, almost fell off my chair there. Let's see here. Another question. Where is this being recorded? Yeah, so all of these are recorded and they're uploaded to YouTube. So if for some reason you have to step away from your computer for a second, this will be up on our YouTube channel. That's youtube.com/KETIV Technologies. Probably be up sometime in the next week for review. Additionally to that, the first AVA that Philip did about the add-ins is also on our YouTube channel. So definitely use these two AVAs in conjunction with one another. They're kind of, an extension. And I'm assuming we'll probably do the same thing for the next one, right? Go a little bit deeper, go a little bit more specific in one particular area. So definitely, if you need to stay sharp or revisit anything that we've done in the last 5 years of doing these, go ahead and take a look at our YouTube channel. It'll be there.
Yeah, and if you have a specific thing, kind of maybe one of those things on the list that I had up there, or something else that you'd like to look into, I'd be happy to hear it. Because of the time nature of AVAs, I mean, we can't get super deep. That's why I did a simple example on this one, but we can kind of show the basics of a lot of things. So.
Yep. Yeah. So if for any reason you need to reach us, go ahead and literally ask anyone here at KETIV and we'll find the right resource for you. So let's see on that. So yeah, thank you everybody for joining us. We'll see you here same time, same place next week. And enjoy the rest of your week and weekend, everybody. Talk to you all soon. Thanks, Philip.
Thank you.